Hello everyone. So for today, we're gonna start our discussion on the next unit. Well, this is a unit on how do we classify uh, compounds. So for this section, we'll be focusing on acids and bases. So many compounds can be classified as acids or bases. So examples of which are the soap that you use, Coca-Cola, orange juice, or even the alcohol or the cleaning material that you're using at home. And both are very corrosive, so never digest or touch to identify an acid or base. So distinct property of acids is that an acid will release an hydrogen ion into a solution. So this is an example um, in this particular equation here. And bases, on the other hand, releases a hydroxide ion into a solution. So an example of its formula is given by that equation there. Sodium hydroxide, well, dissolved in water, you have sodium ion and break up to sodium ion and the hydroxide ion. So if you can remember in our experiment last time of different substances, we used the pH scale to identify a basic or a acidic solution. So a pH scale is just a number scale that indicates how acidic or basic a solution is. So 7 is considered as a neutral solution. An example of this is water. So water is a neutral substance. And anything that is below 7 are considered acidic solutions. And anything that is above 7 are called or are considered basic solutions. So pH is the concentration of your hydrogen ion expressed as a logarithm. So if you're talking about logarithm, well, you'll be learning this one in your uh, maybe pre-calc 11. Well, if you have logarithm is just somehow related to exponent, and uh, the basic logarithm is to the base of 10. So every change in the pH scale of one unit is actually a change in 10 times the concentration of the hydrogen ion. So an example would be if you have a pH of 4, pH of 4 is 10 times more acidic than pH of 5. And a pH of 3 is 100 times more acidic compared to the pH of 5. So you can observe here in pH 3 and pH 5, the difference is 2. But you would not say that pH 3 is 2 times more acidic compared to pH 5, but you will say it's 100 times more acidic. Because actually it is, as I mentioned earlier, logarithm. Basic logarithm is the base of 10. So you have 10 to the power of 2 will give you 100. So actually that's how you compare the concentration of your H plus. So you have here some of the different substances, well, common substances that you can see at home. So if you can see here, hydrochloric acid, your gastric fluid are considered acidic, the lemon juice, acid rain, vinegar, these are bananas, they're actually acidic substances. And pure water, if you can see here, it's neutral, or the uh, pH is 7. And you have egg, seawater, baking soda, and most cleaning materials are considered as basic substances. So these are some of the characteristics of acidic substances. So the pH of acids are from 0 to 6.9, and it contributes hydrogen ions into a solution, and it turns a litmus paper red. So from blue litmus paper to red, it conducts electricity and produces hydrogen ion gas when added to some metals, and it is also very corrosive. So, well, you have there the figure showing the different materials with the pH scale and also the concentration. So the concentration is shown here. So 1 10 to the power of 1, so on and so forth. And acids often behave like acids only when dissolved in water. Often written with the symbol AQ. Again, aqueous, or that particular symbol AQ. We have mentioned this one in our previous discussion on chemical reactions. The subscript AQ denotes that it is an aqueous solution or dissolved in water. The chemical formula usually starts with hydrogen. So, for example, would be hydrochloric acid. So you have there HCl, and then you have the nitric acid. So you have HNO sub 3. Acids with a carbon usually have the C written first. So you have your chemical formula of acetic acid. So you have CH sub 3 COOH. So how do we name acids? So we name acids by, well, we just follow this rule. Hydrogen plus IDE. So if you have hydrogen, chemical consists of a hydrogen and the another element. So we can name it as hydro plus the name of that element, but change it to IC instead of IDE. And then we place the acid name. So an example would be HF. So HF, you can name that compound as hydrogen fluoride. But as an acid, again, in an aqueous solution, it is hydrofluoric acid. So you have here, one that changes is the hydro remains, but you take out the GEN of your hydrogen, and instead of fluoride, the IDE part, you change it to IC. And then how about if you have a compound with hydrogen and again ATE as the for the second element? So an example would be H2CO sub 3. So we call it hydrogen carbonate. However, as an aqueous solution or as an acid, we call it as carbonic acid. So we try to omit altogether the hydrogen part. So it just becomes carbonic acid. And the third one is that you have hydrogen plus a second name ending in ITE. So we change it to, again, there's no more hydrogen, but instead of ITE, we change it to OUS, then acid. So example of which would be H2SO3, the chemical formula, and we call it as hydrogen sulfide. So instead of that, we will call it sulfurous acid. So if you want to know know more, well, more examples on how to name acids, you can um, you can visit these YouTube videos here, and well, uh, it's actually a good video. So uh, again, you can visit this one. So that's all for today. So the next video would be on bases. We're going to be concentrating on the bases, and then after which I'm going to give you some worksheet to do. Okay, so have a nice day everyone, and good morning, good night, or good evening. Well, until then.